That's the X and Y axis you see there, and the center of it is the Z axis. And in this stone, you can actually sort of see it. It's so perfect in the stone that you can see. Now, a light behind me. Okay. There it is. And that is the perfect center of this cubic crystal. And it creates a prism-like arrangement inside the crystal structure. And that gives it the rainbow colors. There's no treatments on here. There's no thin film diffraction going on. It's the passage of light across the angles of a triangle. And when it crosses the boundary, it bends. Each time it crosses a boundary, it bends. Okay, so it goes across, boom, 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 in a straight line. But on this side, it starts bending. And this one bends first before this one down here, because it had to travel less distance, this one up here did, than this one down here. And so we have rainbows that are they run from red to blue. Red, orange, yellow, green, blue, indigo, and violet. And so this stone, in its perfection, has all of those colors as you move it across the boundaries. But it also, because of the reflections in there, and that's what's causing a lot of this optical stuff that you see, is the reflections. Okay? So watch carefully, and you will see that there's a cube within a cube there. That is called a tesseract. It is a four-dimensional space. In other words, this cube here is three-dimensional to us: length, width, and depth. Okay, and diamonds always have some sort of box-like structure on their crystal. And that's what makes them cubic in one direction. But if you look, count the number of sides you can see. 1, 2, 3, 4, 5, 6. And so at 90 degrees, it's six-sided symmetry, but it's cubic hexagonal. It's not just cubic. It's not like fluorite or salt, sodium chloride. They have a three-dimensional structure that is isometric. It is even in the three cardinal directions. what you're seeing inside there is a reflection of the lines within the crystal. See, stretching and it's a mirror in there, and it changes as I move it. And that space in there can be shown to be infinite, because all numbers have infinities kind of built into them. But in this case, it's the reflections of this other cube, this three-dimensional cube in our regular universe that has created this fourth-dimensional space. And it is, as far as I know, the only natural tesseract in the world. Now, I have a couple of them, several of them. This is diamond, I believe. I made this a couple of years ago, and I didn't quite know as much as I do now, but it is diamond, as far as I can tell, and you can see the little squares in there at the bottom. Those are on the surface of the stone, and I'm trying to get rid of them. And it's real hard because diamond's real hard. And when I got this, it was rough on these edges. It was this perfect cube, but the edges and the top followed these lines, planes of cleavage, in the crystal structure, and that's a diamond, folks. That's the most perfect diamond in the world. That is not some technology that I put together to fool people. I don't do that. I don't have to do that. The real world is full of totally amazing things. I don't own Photoshop. I don't approve of Photoshop. Photography should be used to convey accurate information. Information that you can count on. The Starfire family wishes you peace and prosperity ad infinitum.